Hello, and welcome to Chartek Fireside Chat, an informative series on the wonderful world of passive fire protection. I'm your host and presenter, Bill Dempster, Fire Protection Market Manager for North America. It's a real pleasure to be here with you today. This session is titled Multi-Sectional Assessment in Hydrocarbon Fire Applications, and we'll review the technical and commercial aspects of implementing proven multi-sectional assessment of passive fire protection material. Examples from project data will be used to demonstrate the influence of multi-sectional assessment on material and project schedule savings. Episode 1 will cover current practices, industry position, and technical justifications for utilizing multi-sectional assessment. Episode 2 will cover the beneficial commercial implications and the positive effects on the overall passive fire protection bid package. And in the final episode, we will introduce the concept of performance-based fire protection and demonstrate the practicality of considering industry best practices to optimize the performance of your passive fire protection system, resulting in additional project savings. So, without further delay, let's jump into the deep end and get started with episode 1. Hi, welcome back to Chartek Fireside Chat. I'm your host, Bill Dempster, Fire Protection Market Manager for North America, and I'll be your presenter for episode 1 of multi-sectional assessment in hydrocarbon fire applications. Let's get started, and I hope you enjoy the presentation. So, a few facts of the industry, and I'm sure after reading these, you've probably experienced the same feeling as this poor soul is on the right-hand side. The telltale sign is here in North America in the final bullet point. A 2015 industry survey, 15% of all NAM projects, these are new construction projects, experienced significant project delays, and 51% experienced budget overruns. These are still going on today, and that tells me as an industry, we have some serious challenges to overcome. As a fire protection supplier of a lot of these new construction projects and on M&R projects, we hear the same comments. It's that dang fireproofing. That's what's causing the delays. Well, the fireproofing does lie within the critical path for fire protection of steel. But let's take a deeper look into what this means and what's causing people to say this. So the current legacy approach to passive fire protection in the hydrocarbon market is pretty straightforward. It's a single thickness approach. That is a single dry film thickness on a W10 by 49 column for all hourly ratings. It simplifies the spec, it simplifies the application, and all you need to do is when a RFQ comes out, say for 50,000 square feet of a 2-hour UL 1709, all you need to do is go into the UL Design Fire Resistance Directory, look up the UL Design, and under the hourly rating, look over across for 2-hour rating, and you have 8.67 millimeters. Pretty straightforward, pretty simple, and it's been an acceptable practice since the 1990s within the industry. So the question I have is, what decided on a single thickness on a W10 by 49 column? Are all projects consistent of W10 by 49 columns? And what is the project complexity of the steel? Well, if we look at steel section distribution, this happens to be an example of 4 projects. We can easily see that there are some steel sections that are greater than a W10 by 49, and there are some steel sections that are less than a W10 by 49 steel size. Does one size fit all? Hold that thought, and we'll answer that question a little later. If we look at the UL 1709 XR series designs, either XR 700 series, which is for the cementitious material, or we look at the XR 600 series, which are the epoxy and tumescent material, and I did not include on here boards or other types of passive fire protection material design listings. But you can see there are 22 design listings for cementitious materials using single thickness approach, UL 1709 on W10 by 49 piece of steel. So you look across at the hourly rating based on minutes, and you look up the dry film thickness, and that applies to the entire project. Same thing with the epoxy and tumescence. There are 31 design listings, and these go back as far as the mid to late 1990s. So in total, there are 53 designs. So what's the industry position? How does the industry feel on using a single thickness approach? So I looked at different types of recommended practices, different third-party testing agencies, and what's really driving the system is really the American Petroleum Institute recommended practice 2510, 2218, and also the Underwriter Laboratory UL 1709. What are these positions and what do they mean? Well, let's try to summarize these for you. So, as early as API 2510 1996 version, a statement in that recommended practice is that the thickness of the fireproofing should be equivalent to a fire endurance of 1.5 hours per UL 1709 when tested on a W10 by 49 column. API 2218 further goes on to say that a W10 by 49 structural steel column is a de facto standard for structural steel, and that any steel sections with greater or similar mass per unit or W/D ratio can use that same thickness and be covered for the same hourly rating. However, you have to understand that structural steel with these higher W/D ratings could also have a higher fire rating. That is, if this W/D section on a W10 by 49 is for 2 hours, if you go over that steel size, you could actually have 2.5 or 3 hours. And this comes from API 2510 1999 version. If you wanted to go on steel sizes smaller, UL states that you must test down to that small size. So in fact, if you have only testing to a W10 by 49, you cannot extrapolate or interpolate down to a smaller size. You just won't have covered. If you want to cover those small steel sizes, you have to go ahead and test. So for example, on this chart, we went and looked at a W6 by 15 so that it would cover these steel sizes less than a W10 by 49 and be accepted by UL 1709. What you're really setting yourself up for is if you look at a single thickness DFT, which is the current practice, and then you look at a multi-sectional where you've got multi-temperatures run over a gamut of different steel sizes, you could potentially run into what you would call an over-under situation. That is, any steel sizes less than a W10 by 49 will be underprotected. So if you have a 2-hour rating, a 2-hour thickness of, say, 8.47 millimeters, anything under that steel size or section factor, you probably won't have a 2-hour rating. You might only have an 1.5-hour rating, or you might only have an hour rating. And any steel size is greater than that, you could potentially have overprotection. So a W10 by 49 steel section with steel sizes greater than that, or a W/D ratio of greater than W10 by 49, you could have greater thickness on there, which is really overprotection. You've got too much on there for a 2-hour rating. You could actually have the thickness equivalent to 2.5, 3, or 4 hours. What you're really setting yourself up for is using a single DFT approach. You're looking at risking steel sizes smaller than a W10 by 49 of having not insufficient fire protection, and you're looking at an overspend. You're putting on too much material, way too much material in some instances, simply because you wanted to use a single thickness approach on a single piece of steel on a W10 by 49. Now, if you had gone and looked at a W6 by 15 or a W6 by 18, you would have been up in this area here, which you would have reduced the risk, but you would have had a greater overspend because they have way too much material on those larger steel sizes. What we did to take a look and evaluate this is we looked at a series of fire tests. We evaluated a W10 by 49 piece of steel with a 2-hour UL 1709 rating. We looked at 2 fire furnaces at 2 separate agencies, and then we took that thickness and applied that to different steel sizes, some greater than W10 by 49, some smaller than a W10 by 49, and then ran a fire test to see where the critical core temperature was reached and what the time was. And we found some interesting things. First of all, sections that have large sections, we actually were able to determine that a W10 by 49 thickness using a single thickness approach really gave you greater, some instances up to 160 minutes on the steel sizes we tested, which is way too much material for a 2-hour rating at 120 minutes. More importantly, we looked at steel sizes that were under a W10 by 49, and in those sections, they had upwards to 80 minutes, less than an hour and a half rating on smaller steel sizes based on a W10 by 49. So what we essentially did was verify and support what UL, what API we're stating all along. So what changed? What's the new norm? And what are people looking at now? Well, since we've become a global market in the oil and gas industry, we're now starting to adopt practices that are used on a regular basis on type certificates for the offshore market, and we're looking at certificates used quite regularly in the downstream market that both use multi-temperature and multi-sectional assessments. The new norm has been established in UL 1709 Edition 5. And what it does is it provides provisions in there for multi-sectional assessment right in the test standard. It also provides for potential of using structural fire design opportunities. It considers different steel shapes, different steel sizes, and we also look at a potential loaded beam testing. It captures all of the global practices currently used in UL 263, which is the cellulosic equivalent of UL 1709, which uses on a regular basis multi-sectional assessment, and also in the oil and gas markets with type certificates similar to, say, Lloyd's, ABS, or DNV, and maybe some some downstream markets such as British Standard. What it does now is you look at the critical core temperature of 538C. Instead of having a single thickness approach based on the hourly rating, what you now have is steel sizes. This happens to be a section factor of HP over A, or you can use W over D factor. And then the different hourly rating periods, and you would go across and pick out your steel size. Say on this one, for example, a HPA over 300, we read over to 60 minutes, and we have 9.15 millimeter thickness. And we can go all the way over to a 240 or 4-hour rating, which gives you 25.5. Now what you have is steel sizes that dictate how much fire protection is put on them to protect them for the hourly rating. So what's happening now? So remember we looked at XR 700 series, which is the cementitious materials. We now look at 7 materials, 7 products. And this is the hourly rating for a 2-hour UL 1709. This is the multi-sectional approach where you've got different steel sizes. And you also have the single thickness approach. You can see the difference. Same thing with the UL 1709, 2-hour rating for XR 600 series. And that is the same with a single thickness DFT. You can see the difference here. But we don't sell thickness. What we are selling and what we are looking at and what is driving our projects is volume, the amount of fire protection material on the steel. And that's what these charts and these tables also show. These not only show the multi-sectional thicknesses, but it's been calculated to show the amount of volume in pounds per square foot. So how many pounds of cementitious material? We typically will bid these in a bag price or a bag, 50-pound or 40-pound bag. But these are the volume of pounds per square foot based on the steel size for a 2-hour hourly rating of UL 1709. And this is the same situation we have with these the epoxy intumescent materials. You've got volume based on pounds per square foot, based on steel size. You can see the big difference in the volume, and that's really the driver. So if we were to look at, for example, on the chart on XR 600 series, the green line at the bottom, we'll just look at, say, a W over D ratio of, say, 1.5. With using a multi-sectional approach, we're looking at about 1 pound per square foot. If we go and use a single thickness approach, which is what the legacy approach is being currently used, you get about a 2.5 pounds per square foot. So what does that mean? That means that on a 10,000 square foot project, you're looking at a savings of about 1.5 times 10,000 square feet. That's a considerable amount of material savings. That's where the real beauty of multi-sectional assessment comes in. It allows you to look at, it allows you to save material, and it also allows you to save on scheduling because you don't have as much material to put on the steel. So in episode 1, what are the key takeaways? The legacy approach is using one-size-fits-all really doesn't work for one-size-fits-all. It may have worked back 20 years ago, but not now. The steel is more complex. You simply cannot use a single thickness approach, and it's out of date. This is a single thickness approach is predominantly utilized in the North American hydrocarbon market. Everywhere in the globe is using multi-sectional. And the legacy approach is recognized by UL and API as an over-under scenario, where you've got an under scenario where you're at risk, where you have insufficient fire protection, you're at risk of causing premature fire failure on your facility, or an overspend, where you have excessive fire protection on the steel and you're paying way too much for putting way too much material on that steel. The multi-sectional assessment is one that's used quite regularly. It's based on steel section size factor. It's universally utilized on global commercial and hydrocarbon fire projects. And it's a steel-driven fire protection. That has been recognized by UL 1709 and the current API 2218 documents. Matter of fact, if you go into the appendixes in the back of the new UL 1709 version 5, it gives you a whole procedure on how to use multi-sectional assessment. And finally, multi-sectional assessment offers potential project savings at zero cost. You don't have to go to an engineering firm to reduce the amount of fire protection on that steel. All you have to do is use multi-sectional thickness. It's already there. The testing's already been done. All you have to do is use it on your project. So how do we go ahead and do that? What do we do next? How do we give you, and how do we apply that to a commercial application? Well, that's in episode 2.